I built a drone from scratch using an Arduino Nano. I'll show you how I went from this to this.
Whoa!
Just kidding. While making the drone, I made almost every possible mistake, and I went through 4 different flight controller designs, 2 different microcontrollers, and 5 different religions. Each time praying to a different god for my drone to fly. I started with a prototype just so I could familiarize myself with Multiwii. I've also never really been a hardware guy. This is pretty much my first serious electronics project. Multiwii is the firmware that I used, and honestly, I wish I had switched to something more modern like Betaflight or Arduino earlier with STM32. The first thing that appears when you search Multiwii is a Reddit post asking how outdated Multiwii is, and that was 7 years ago. It's not well maintained, it doesn't support that many sensors, and the Arduino itself has a low clock speed and is just too slow to support things like Express LRS, which is specifically for drones and very low latency. It's just plain old. Do not go down this path if you want a really good flight controller, but I did learn a lot in the process. After the prototype, I tried making a perf board since I didn't want the wires falling out mid-air, but I got sick of it, so I switched to a PCB that my dad had designed. This was so close, but it never flew because I had the gyro orientation wrong the whole time, which I realized after looking at the Multiwii, the model of the drone in the Multiwii GUI. Also, it probably didn't help that the gyro was connected by some jumpers, and I had it in the back of the drone most of the time.
Oh, brother, this guy stinks!
Not in the center of the mass. I then decided for some reason that my drone wasn't working because of vibration, although I doubt that something as small as vibration would have ever caused such huge issues. It probably would have just led to wobble and drift. So I myself designed a custom ESP32 flight controller and ordered it from JLC PCB. This was promising, but maybe failed because the gyro was LGA, meaning the pins were underneath, and so it was hard to solder even with my hot air rework gun and flex. It's actually writing. I have no idea what happened. I don't know why it's working all of a sudden. It's working. It's working. I'm not sure if this is a legit strategy, but right here I've tinned every pad. Make sure they're not shorting. Doesn't look that great. I think this pad right here might be needed a little more or something. But we got our bag goodies here. We use a hot air gun right here. Apply it. Wiring on the schematic. Either way, the gyro just didn't work. But the nail in the coffin was when my voltage regulator broke and the ESP32 went dunzo. Just for the sake of saving money and time, I went back to the Arduino and made a little perf board. Say hello to the brand new flight controller. And very quickly saw success after switching the gyro orientation. While I wish I could have gotten the ESP32 flight controller working, because that one was by far the most modern and cleanest I could have even used something like Archie Lopez's ESP flight controller firmware that's even compatible with the Betaflight configurator. I can only fly the Arduino drone in Acro because the gyro on my perf board isn't level, and I could just press it down, but I feel like that's a little inaccurate, and everybody knows that the flight mode of choice for beta males is angle mode and the DJI loving CCP sympathizers.
我在北京。
老天保佑金山银山前途有，老天教唆别管家。
The drone is itself unstable, but if I was really going for full stability, I would go with Arduino with a GPS and a barometer, which relies on air pressure for altitude hold. But for now, I'm going to try to see if I can just become a better pilot. Acro Mode, for those of you that don't know, is short for Acrobat because you can do cool things like flips and there's no self-leveling. It just relies on the gyroscope, not the accelerometer. The accelerometer actually tells you the orientation of the itself, but the gyro basically just measures angular velocity. In the following videos, I'll be making an autonomous drone and a Nerf gun. You can see that Nerf gun jams, which is something I'll have to solve later. I'm using an Orange Pi for the autonomous drone part. Why Orange Pi? The community is non-existent, and the cameras aren't ideal for making binocular vision, but for depth mapping. But it's cheap, and it's got a built-in neural processing unit with 6 tops, which means I can save a lot of money and weight because I don't have to buy those AI hats. Anyways, thanks for watching, and subscribe so you don't miss out on future projects.